All right, welcome back. We're going to start with Unit 2, which is going to be about deployments. So let's talk about applications in Kubernetes. So with our Kubernetes cluster, we start with the manager node. It doesn't run any applications itself. It just coordinates the rest of the cluster. And then we have one or more worker nodes. And on these worker nodes, we're going to want to run one or more applications. And typically we want to run as many of these applications as we need in order to actually fill up all the capacity of our worker nodes. So what really is an application in the Kubernetes sense? Well, an application is really a container image. It combines the operating system, application, key configurations into one manageable executable unit. Now, Docker images are the de facto standard for what these container images look like. And these container images are actually just a tar.gz file containing an entire operating system root file system. Really, that's what they are. Docker images are only one of these standards, however. There are multiple different kinds of standards available that will actually allow you to run Kubernetes with different kinds of containerization systems. Rocket was one of them that's been around for just as long as Docker. But Docker by far is the most popular standard for container images. So where do we get these images? Typically, we get them in a few different ways. We can use or modify some public images, or we can build our own. Either way, we need to start by looking at a container registry. A container registry hosts container images. These can be shared in public or private and self-hosted. Docker Hub happens to be the largest shared container registry available on the internet today. You can find it at hub.docker.org. Now, when we're downloading stuff from the internet, even in 2019, downloader beware. Always security review public images that you are going to see, that you're going to get from the internet, because you never know what's going to be in them. There's something that's called a supply chain attack, where at one point in the process of building and getting that image, malicious code becomes infected into the end result. And as a result, it's much more difficult to check it because it's somewhere upstream from the point that you downloaded it from. So always security review any public image that you're going to download from the internet. Then a set of images we're going to use for this class today is Flight Deck. It's 10.7's own Drupal and Kubernetes friendly containers. We have actually built this ourselves to be Kubernetes native to run Drupal workloads or really any PHP workload, and make sure that it is as secure by default as we can make it. You can find the source code for it on github.com/10.7/flightdeck. All right, so now we know where our container images are. How do we get them onto Kubernetes? So we want to put applications on our worker nodes. Do we just call them applications? No, we don't call them applications. In Kubernetes, we call them pods. Now, if you're a networking person, this is where you're going to groan here, or if you're a marine biologist, this is where you're going to groan here. But also, Kubernetes, in a Kubernetes sense, a pod is a running instance of an application. Now, this gets to slippy territory. I've heard of containers before, but what are these pods that you're talking about? Well, a pod can be one or more containers. Each container shares the same local host, so the same concept of its own network identity. This also includes things like IP address, DNS names. It doesn't really include volumes, but it can depending on configuration and a whole bunch of other stuff. So when you look at a pod can have one or more containers in it. So we'll have a pod that has a container in it called container A. This container A is based on a container image called image A. Likewise, there's another container in this pod, container B, which is based on image B. And before you completely lose your mind in trying to keep track of this generic stuff, let's actually make this a little bit more physical. And let's say that we're going to have two containers in our pod, one called web and one called varnish. And the web container is based on 10.7 Flight Deck Web, and the varnish container is based on 10.7 Flight Deck Varnish as the image. So there we go. That's what our pod is. We can call this a web engine because it combines Varnish and a web server such as Apache. Now, why would you do this? Why not just run the containers as their own single unit? It's one of the weird things that's about Kubernetes compared to, say, a Docker Swarm. But there's a few different real good reasons why you would want to co-host multiple containers in the same pod. This ensures tight coupling where it's needed. Things like Apache and Varnish, those really should have some tight coupling so that you always have one Varnish for one Apache instance. Or a better example might be Nginx and PHP FPM. You'll need Nginx in order to handle the web traffic and PHP FPM in order to actually operate on the PHP side of the request. So those are good candidates to co-host containers in the same pod. And the next thing that's really frustrating about Kubernetes, and the first thing that I found out when I was trying to figure out how to run Kubernetes, is you really can't just run a pod. That's not really true. You can, but it doesn't quite work as the same as compared to, say, Docker Compose or the base Docker command. This is what's called a static pod. You can, in fact, deploy a pod, define a pod by fiat on your cluster, and have it run. But this is considered generally a very bad practice. It's called a static pod, and rarely do you ever want to create these directly. Instead, you want to create them indirectly through a managing object. One of these managing objects is called a deployment. A deployment describes an ideal state of a pod and can run multiple replicas of that pod. So let's say that you have a web application that you're running, like Drupal, and you want to have at least 3 web front ends. Every front end has Varnish and it has Apache. So Varnish Apache, Varnish Apache, Varnish Apache. 3 different copies of it. That is 3 replicas of the same pod that has 2 containers in it. With me so far? So how do we define these deployments? There's 2 methods. You can, in fact, use kube create and then the object type. And the honest truth is, I hate this method. I hate this method so much. And the reason why is because every one of these create methods has a huge, lengthy list of switch operators necessary to define all the details of the object. And it's only unique to this create command. You never use it again. A far better method is to use kube apply and then pass it the path to a file. Now, why do this? Because the file is in YAML format, and it's the same format that you're going to be using when editing or updating an existing deployment on the cluster. So why learn anything else? Files are just better. It's the same format as when it's edited, and it can be easily added to version control such as Git. Now, everything in Kubernetes is YAML. It's an indent-based markup format, and all Kubernetes objects are created in YAML. You can create them on the command line, but that's boring. Let's not do that. What's the general format of one of these YAML files? Well, they look like this. They have a short header section, a metadata section, and the body of the entire document is the specification or spec. The header section really only has 2 bits of information in it, the API version and the kind of object that it is. Taking the last one first, the kind of object that it is going to be, in this case, a deployment because we're defining a deployment. Now, the API version is a little bit more confusing. It's not going to be the version of your application. It's not going to be the version of Kubernetes you're working with. It is the version of the Kubernetes API that you're defining this object in to Kubernetes. So it really has a very specific string that you need to use. And honestly, I can't keep track of these myself. I have to look them up too. Generally, apps/v1 is going to be very common for an API version, but go ahead and look up how to create a deployment in Kubernetes, and you'll find out what that API version should be pretty quickly. Next is the metadata section. The metadata section is going to contain key information such as the name of the object, any labels that we're going to apply to the object, which are key value pairs, and something called annotations. Annotations are kind of like a label. They're a key value pair, but they're used for configuration and modification of execution. Typically, we're not going to see that in this class, but we will actually see this in much more advanced configuration so that you know what that special word is, annotation. Here's what a metadata section looks like. It's pretty simple. It's got a label section with one label defined in it, app equals web, and the name of this object is just going to be called web. The label doesn't have to correspond to the name at all. This is just happenstance. Then there's the specification section. It's the main body of the document. It defines the object or template of objects to create. Template of objects. That's going to be very important for us going forward. So the deployment spec is going to specify the number of replicas, a selector, we'll use this later, don't worry about it, and the template of the pod to create. Now you can create pods directly, as we've already discussed, but it's bad practice. But a deployment contains a template of a pod to create. That pod template is like a YAML document itself. It has its own metadata and its own spec section. So here's what a deployment looks like. API version app/1, kind equals deployment, name equals web, and then we have the spec section. We'll notice that there's one replica in this spec. There's a selector that we're going to ignore for now, and then there's the template section. The template section is going to have a whole bunch of other stuff that looks like its own separate document. And it is. It's going to have a metadata section, which has app equals web. And then it's got its spec section, which has a containers section in it. And here is where we get down to where does the container get specified. It's here right at the bottom in the container section. Image 10.7/flight deck Drupal : latest. And we'll name this container web and open port 80. So there we go. There's where that container is. So how do we work with these deployments now that we actually have the file created? Every time we need to work with this, we're going to apply it to the cluster. This deploys the definitions to the cluster and will actually update the definition in place. So kube control, pass your kube config file as a switch, then apply -f and the path to your YAML document. Every time that you do an apply operation, Kubernetes is going to validate your document first. It's going to be done by kube control before it modifies anything on the cluster itself. This operation is transaction-like. So if your YAML definition has a typo or a wrong indent or completely doesn't make any sense for some other reason, the application will fail and it won't create any partial objects on the cluster. This is very important because it will save your butt multiple times. What if we need to update a deployment that we already deployed? Honestly, it's the same command, kube control apply -f and the path to the file. The existing object won't be replaced with a new definition, but will be patched. It's kind of like a git merge operation. So if there's a change on your file that's not in the cluster, it gets applied to the cluster. If there's a change that's on the cluster that's not in your file and wouldn't be overwritten by a similar configuration, then that change remains on the cluster. And this behavior is default and enforced. So keep that in mind anytime that you're working with Kubernetes. How do we list these deployments? Honestly, this gets into familiar territory that, like we did with nodes. Kube control, pass your kube config file, and then get as the verb, deployments as the noun. So get deployments. Pretty easy. And that will list all the deployments that are in our cluster. And we can see that there's one deployment here, name is web, it's ready and up to date and available, and it was deployed like 9 minutes ago. What if we want to get further details about a deployment? Kube control describe deployment and then the deployment name. This will include some operational information such as the pods, the amount of memory or CPU that it might be consuming, but this is generally not where I like inspecting this information. There are better tools available for that. One thing that's really nice about Kubernetes is you can do hot editing. Sometimes this edits the definition in place on the cluster without having to go through the normal kube control apply -f workflow. You edit it in line on the cluster without doing any other process. Now, why would you ever want to do this? That sounds like a recipe for chaos, and it kind of is. But it's generally used best for critical fixes or for troubleshooting when you want to avoid the normal workflow process of deploying an entire new configuration through your continuous integration system. This way that you can do it quickly, you can do small changes iteratively until you figure out what the problem is. How do you edit? Kube control, pass your kube config file, edit, deployment, and then the name of the deployment. Really straightforward. Now that we have some deployments on there, we need to work with the pods because a deployment doesn't create, running deployments. It creates running pods. A deployment is a template for pods. So now we need to work with the pods themselves. How do we list them? Easy. Kube control, get pods. Pretty easy. Pass your kube config file, get pods, and you'll notice that you'll have a list of pods. Now, depending on the number of replicas that you selected for your deployment, you'll see 0 or more entries in this list. In this case, our deployment says that there are 3 replicas. So there are 3 copies of our web pod, and each one starts with web as the name. This is intentional. Every pod is going to start with the name of its deployment, followed by some hexadecimal garbage. Now, that's going to come back and haunt us in the future, but this is actually by design, and we'll find out why in the future. Okay, so far so good. So these pod names are in the form of deployment name and a unique identifier. And these names are non-deterministic by design. It's actually intended so that you don't actually rely on host names when you're using a best practice deployment configuration. That way that you always have to use either some other mediary object in order to get to them. And we'll find out how that works in a moment. But let's say that we have our deployments on our cluster, we have our pods running, we want to actually get into one of the pods and run some commands. So how do we get a command shell? Well, there's kube control, exec, exec, -it, and then the command to run inside the pod. So that command to run inside the pod is something like bin/bash to get an interactive shell. But it could just as easily be a command you want to run directly, like drush. That will work too. The -i-t might be unfamiliar to you if you're only using Docker Compose, but -i means interactive, -t means simulate in a terminal. And this is a bit of techie underscore knowledge that's necessary in order to tell Kubernetes, yes, we want an interactive session. So -it. What does this look like in a whole command? It looks like this: kube control, kube config, path to your kube config file, exec it, the name of the pod, not the deployment, the pod, and then the command to run inside the pod. There we go. That's the entire command. So now that we have our deployments on there, our pods running, we know that they're running, we can interact with them. How do we actually get to them? We need to get to them. How do we expose these deployments to the wider world so that we can actually access them? We have a web server on a pod somewhere. We should be able to direct traffic to it now, right? How do we do that? So we have our deployment in our cluster, and it has 3 replicas. Now our web browser will come along and go, well, I need to talk to our site, and I don't know which one of these to talk to. I actually have no idea. And worse, I have no idea because each one of these has a non-deterministic host name, so I can't even guess what they're supposed to be. Wouldn't it be great if we had an intermediary bit of technology that handles this for us? And we do. A load balancer will allow us to request traffic to a consistent endpoint, and the load balancer will direct that traffic to one or more pods as necessary, and will load balance between multiple pods for successive requests. So that's pretty great. That will make our browser nice and happy because we have a single point of entry. This load balancer is defined in Kubernetes as a service. So services are consistent application endpoints. Every time you define one, it creates an internal DNS name that is known cluster-wide. Here's what a service looks like. You'll notice that the API version is different. It's not apps/v1, it's just v1. I don't know why it's like this. It's confusing to me too. I feel your pain. Kind is service. we have a name called metadata equals web, and then we have a specification section which lists the number of ports. And in this port, we're going to have one port open for HTTP traffic, for TCP traffic, which we call HTTP, on port 80. Also, there's a selector there. Huh, that looks familiar, doesn't it? Selector app equals web. Where did we see that before? So let's talk about selectors. A selector is actually kind of complicated. In previous versions of this class, I actually made it a little simpler. It's a little bit more complicated, has lots of nuance. So it associates the deployment to the pod, even though they're in the same template, and then the pod to the service. So here's our deployment definition. So we have a selector which is called app equals web in our deployment. So this deployment will manage pods with the label app equals web, and that needs to be unique across our entire cluster. Next, down further, we're going to have our template, and we have a label section. And the label section for our pod template is app equals web. So those two combined actually show how the deployment maps to the pods. Even though they're in the same template, they don't necessarily have to be. It gets really complicated. Now let's scroll down even further and we'll notice we have our service definition, which is oddly, looks like it's in the same file. Interesting. Well, let's just say for the moment we have our service definition, API version 1, kind equals service, metadata equals web, and then it has a selector. And this selector means that anytime that someone talks to this service, talk to pods that have the selector app equals web. So these two meet in the middle. Cool. All right. Moving on, you'll notice one thing that we also did with this, which is kind of weird. We combined multiple definitions of YAML into the same physical file. Why the heck would we do this? Can we do this? Drupal doesn't do this. Well, Drupal doesn't do this by choice. YAML doesn't care. YAML actually supports YAML multi-doc, which allows multiple roots of YAML, effectively separate YAML files, in the same physical file, and each one is separated by 3 hyphens on its own line. This is optional, you don't have to do this, but it's really useful for highly related definitions like a deployment and the service. And depending on your automation system, you may or may not want to use this, but it's really useful when working with Kubernetes definitions directly using this relatively bare bones method that we're using in this class. How do we manage services? You already know how to manage services. Kubernetes, kube control get services, describe service, edit services. Very, very straightforward. It's the same commands and the same verbs that you already know. So nothing new has to be learned. Awesome. Now, another thing is that services also have multiple service types underneath the covers. The default is called cluster IP. It's for internal traffic only. It doesn't leave the cluster. There's another one called node port, which exposes the same non-deterministically numbered port on every individual node in the Kubernetes cluster. If you're familiar with Docker Swarm networking, this is kind of like how that works. And then there's load balancer. And load balancer is what we're going to use because it provides external access. So to change the definition for our service, we're just going to add at the bottom of our spec, type equals load balancer, and that will create an external access point for us to talk to our web pods. Great, awesome. Now it's time for lab 2, and the overview of the lab is first you create the deployment YAML, then you're going to apply that YAML to the cluster, observe how that works, work with some pods, and edit the deployment. And I'm sure there'll be some services mixed in there too. All right, let's go.